Hi folks, welcome to an introduction to simple and compound interest. So we got a dilemma on our hands, but a good kind of dilemma. We've been offered two offers for investing our money at some competing banks, but you can only choose one. So the first one we'll say is Big Bucks Bank. They offer a 100 million% return every day on an initial investment of 1 cent for 30 consecutive days. So their 100 million% return will only apply to that initial 1 cent. So that means we're going to be receiving $10,000 every day for 30 consecutive days. And the other bank, Modest Bank, they take a more modest approach, obviously. They're going to start with your 1 cent investment and they're going to double it every day for 30 consecutive days. So on the first day, you'll have your 1 cent will double and it'll turn to two. So you get 2 cents. And that's assuming we leave our 1 cent in there every day. So we'll just keep that assumption that we're going to always leave the extra money in there. Um, and let's see what happens. So 2 cents, if we double that, we'll get 4 cents on the second day. On the third day, our 4 cents, we double it four, it gives us 8 cents. And so we continue this trend for 30 days. So the real question is if these are competing banks, I know this might seem like an obvious answer to most of us, but we're going to determine which investment option is better for us. Now, just an FYI, the second, just to compare interest rates, kind of compare interest rates. So the first one was 100 million% was the everyday, that daily interest rate. The second scenario where we're doing this doubling, that's like 100% daily interest rate where this investment is being compounded daily. So let's kind of go through the comparisons and see what happens, and hopefully all of you know what's going to happen already. So for our first option, where we receive $10,000 every day for 30 consecutive days. So on our first day, we have with that 100 million% return, you get 10,000. On the second day, you're going to still get that extra 10,000 on 100 million% on the 1 cent that you initially invested. So every day you're having 10,000. Well, an easier way for us to write this is 20,000, or 10,000 times 2 might be a little bit simpler for us. So that's 20,000 there. Day 3, we're adding another 10,000. So you have three 10,000s there. You can write as 10,000 times 3, which is 30,000. And we continue this process until we get to day 30 is what we want to figure out. Well, that's just going to be, if you look at the previous examples, 10,000 times 30, which is $300,000. Well, the other one was only earned in pennies. This seems like a no-brainer. Now, so just a recap of what's happened here. This investment with the daily interest rate of 100 million% being applied to our original investment, this investment would mean our final amount would be 300,001 cent because of our initial 1 cent added in. Okay, so obviously a lot of money for 1 month's worth of just letting your money sit there. Seems like a good option. Big Bucks Bank should be the way to go. Well, let's just take a look at Modest Bank and see what happens. So you start off, and we've had the numbers written down. You start with 2 cents on the first day because the 1 cent doubles. And we're just going to run through the scenario where we leave all our money in there. The second day, our account grows to 4 cents. The third day, we talked about we double that. We get 8 cents. So we'll start from day 3 and we'll just calculate a few days, see what happens. So day 4, double 8 cents, you get what? Well, 16 cents. So now if we double the 16, 16 times 2 should give us 32, so 32 cents on day 5. So day 6, we double the 32, and then we'll get 64 cents. Day 7, 64 cents times 2 gives us 128. So this would actually be $1.28. So notice the other one we were earning $10,000 a day. On this one, day 7, you're only earning $1.28. So obviously, once again, might seem like a no-brainer. Day 30, though, we'd have to continue this a while. So in mathematics, what we often do is rather than work harder, we try and work smarter. And that's what we'll try and do in this case. So the first day we doubled. So we take 1 cent times 2, we get 2 cents, right? Let's try and look at it another way. And so we'll multiply that first line by 2. But rather than write it as 2 cents times 2, we'll write it as 1 times 2 times 2, which is the same thing as 1 cent times 2 squared to give us the 4 cents. Now, day 3, we just add that first line that we see there, the first part of the equation. We'll just multiply another 2. And notice that means just 1 cent times 2 cubed is equal to 8 cents. And so essentially day 4 is 1 cent times 2 to the 4th. Day 5 is 1 cent times 2 to the 5th. Day 6 is 1 cent times 2 to the 6th. Day 7, 1 cent times 2 to the 7th. Notice we always start with the 1 cents, but we're multiplying by 2 raised to the day that it is, that power. Okay, and that's giving us all our numbers. So we're at a buck 28 day 7. By this point in time on the other one, just let me remind you, you've earned 7 days worth of $10,000. It's $70,000. Okay, $70,000 to $1.28. So what happens by day 30? So it might seem like a no-brainer. So you get 1 cent times 2 to the 30th. Well, what? Wait a minute. That can't be right. You might want to bust out your calculator and check it one more time. This turns into $10,737,418.24. So almost $11 million. What might have seemed like a no-brainer, it goes a no-brainer, but not the way you might have thought. So the daily interest rate of 100% with daily compounding resembled an exponential growth model, and it led to a final amount of this $10,737,418.24. So obviously this started to grow real fast, especially when we got towards the end. Now, so the question probably on our minds is, how does an investment with a daily interest rate of 100 million% end up making less than an investment with only a 100% daily interest rate when the initial investments are the same amount? So let's take a closer look real quick. So when we looked at Big Bucks Bank, what happened? Well, the 100 million% daily interest rate was being applied only to that original investment of 1 cent. So every time it was the same amount all the time. That concept is known as simple interest, when the interest is only being applied to the original investment. That's it. And so when you're dealing with simple interest, you're dealing with basically a linear growth model. Okay? So everything's growing linearly. Now, in the second case, though, even though we were at a much less 100% daily interest rate, we tossed in that extra compounded daily for our original investment, earning interest along. So what that meant is our original investment earned interest. And then along the way, too, any extra interest we picked up, that's also earning interest at that 100%. And that is the key component, because what that does, this is this compounding daily, in this case, that compound interest is a big component because it models exponential growth. And so when it comes to our own investments, the things we want to start to think about is, okay, am I having something compounding where it's growing exponentially, or am I having it grow linearly, right? And you want to always choose that compound option if you're given enough time. Sooner or later, that exponential growth will start to take over. Now, I say all the time, it does get a bit different because obviously our lifespans, but at the end of the day, what happens is, given enough time, the compound interest will start to take over. Now, just check on lifespans there is the main thing. But overall, hopefully this lets you see, even when the interest rates are drastically different, compound interest, time is your friend, and it can do a lot over time.